Obviously, robustness, we're still kicking that can down the road, but let's actually tackle that. Let's stop kicking that can. Let's break this puppy. And if we're going to break anything, I think breaking that is a very popular choice. Okay. This also has something inside it that could be extracted out into its own function, which is getting the VAT rate for a specific item by looking up in the table. In PHP, it's so natural to write code like this that we do it all the time. Okay, but that can actually be its own function. Your SRP approach of extract all you can. And so we're going to return a VAT code, a VAT rate if we've got one in the table, and if we haven't, we're going to return a VAT rate of 0 for now, so that the function itself always works. Or rather, it never crashes PHP. Okay? And it's easy enough to use. I'm using just an old builder there rather than the partial. But it's easy to wrap that up in a ROP approach, and then we can actually call it and get VAT rates. There's nothing special there at all. The thing is, we've got a problem. And the problem is, we don't actually have a VAT rate for Q, for the VAT code Q. I've made these codes up. I have no idea what the real VAT codes are. Okay, but our fixture we loaded at the very start of these examples, which probably feels like a million years ago, I'm sorry. And we deliberately didn't put Q in there. So what do? Right now, the function returns a VAT rate of 0. Are you happy with that? Would you do something else? Okay, if you're not happy with it, why aren't you happy with it?
Question.
Yes, please.
You mentioned unit tests, right?
Yes.
How the hell did that pass a unit test?
How the hell does that pass a unit test? Well, this passes a unit test. This particular function passes a unit test.
No, how did you pass a unit test that allowed Q in there when Q's on value that's built?
Q could be loaded from a database. Yeah. In fact, I would almost always put it as external data that was loaded. I would never hard code a VAT table into an app if I could avoid it.
Q actually came from someone who rented that product and assigned a VAT code to it and typed Q and then meant to type code.
Yes. It could be data you've ingested from a third-party system.
Okay, why wasn't it filtered out then?
Because it was a bug in the program.
Well, let's assume it got past everybody else.
So yeah, all right.
And we've got this problem to deal with. So there's a few people saying they don't like this solution. They don't like the fact we default to 0. Why don't you like it?
Silent failure.
Silent failure. Yep. Absolutely.
And it will cost me a VAT.
And it will cost you.
I'll have to pay the government even though I didn't charge for it.
Yeah, exactly.
Yep. And the point you're making itself is it's not this function that has the error in it. This function is dealing with an error that's been propagated to it, which is, I think, is the point you're really making, is how the hell did this error propagate that far? Yeah. And the thing is, by silently ignoring it, it's propagating an error and making it so we can't see the bloody error. We don't know there's an error. So that Q could be floating around for ages until some accountant finally gets his hands on it, at which point it might be too late to do anything about it. So how would you handle this? What would you do? You get a VAT code in and there's no actual entry in the table for it. What would you do? How would you solve this?
Somebody said back there about crashing the program. I think that's appropriate here.
Okay. I kind of wish I gave talks more than once, so I could actually put a slide in showing, nuking it from orbit. It's way better than my solutions. What would you do, assuming you couldn't get away with crashing the code? Eventually, someone made you fix it, or they hired someone else to fix it because you wouldn't.
Populate that failure variable that you're
Populate the failure variable. Okay.
I don't know how you're going to orchestrate that.
Okay.
All right. Show that to me, but
I would throw an exception and catch it.
Okay. So we've got take advantage of this error output and put something there. We've got throw an exception.
In the sort of railway track, wouldn't it be set the expected return to be null and then populate the failure track?
Yeah.
Okay.
We don't have a fair.
Right, so very quickly, I don't have a slide for that, so I'm just going to scroll back for a moment. We can't set it to null because we've deliberately type hinted it to say it returns a float.
I have a question mark and then you're done.
Okay, assume 7.0 because it's the one that's actually widely deployed.
There's even an exception here, right? That's the only way.
Can you return floating somewhere?
No, question mark was added in 7.1 or 7.2. You can't do that in 7.0. You definitely can't do in 7.2.
It
It says someone.
so I would throw exception.
Okay.
The other thing is if we return null, it's not composable for the next function in our pipeline as well. I'm not anti-null by any means.
That wasn't a composable function anyway, so that's rude.
Yeah, that's not written in the composable style.
It is.
No, it's got to build around it.
Sorry, it's not written in railway style.
Yes, but once it's got the builder around it, that's composable.
But we have to throw an exception out of here.
You have to throw an exception. Okay, I anticipated that. I didn't know Rob was coming until 48 hours ago, but I anticipated that. So yeah, we could throw an exception. Yep. We've had a robustness check, and we throw something, and the PHP community loves invalid argument exception. That is something I would nuke from Orbit. I hate that exception with a passion. Absolutely hate it.
Invalid that. Argument something.
Yeah.
Just then, in the previous slide,
Yeah, this one?
your exception there is in the builder's
Yeah, no, I wouldn't have put it
function.
there.
Surely,
That's because to fit it all on the screen, I didn't actually show the two functions separately. I apologise, that's my fault. I should have kept them separate.
I would have caught it.
yeah, because the inner function should throw the exception and the builder should catch it and propagate it.
Let's talk about that then. Let's talk about that. So let's talk about the consequences. The first consequence is we're starting throwing exceptions all the place. We actually don't need ROP and this failure thing. We might as well get rid of it, throw the concept out the window because we're not taking advantage of it. Okay? So we don't need it at all. We're not actually, we were saying ROP doesn't solve our problems. This is my thing against invalid argument exception. I hate generic exceptions. The amount of time they waste tracking down a cause, especially when you get a report back from someone else who's running the code. It's not, you're not debugging, you're not operating your code, you're not running that service. So someone's picked one line out of a log and sent it back and it's not enough. Drives me nuts. I absolutely wish we could uninvent it. Specific exceptions, which are the solution, problem with those is they often lead to large try-catch blocks. And they also lead to problems where people do not know what the hell's coming out of these functions because they're off, unless you actually go and read the code. People can get surprised by them. I've spent a lot of time debugging the AWS SDK for PHP, which does a lot of these things. I don't know if you know, but S3 will fail randomly on you because some nodes are not, you can hit a node before it's actually ready to use as it's being deployed. And so you'll get back some errors as a result of that. You know, I am not. We get a failure rate of about 1 in 2,000, I think it is, on our system. But if you retry that request, it'll hit a node that's working and you'll be fine. But writing that retry code, most of the time was spent figuring out what the sodding hell was being thrown back so we could catch it and only that specific circumstance for us to retry.
The dependency graph problem you pointed out initially was that you don't know what your caller's caller is caller's caller,
Exactly.
and they could all have their own exceptions.
Yeah.
And if you can't catch it, it's just going to bubble up, right?
Well, that's why you catch it.
Catch it in your builder. No, because your builder's returning a function that's already...
If you've got failure in your builder, so you think about the exception.
Well, I've got an answer for that one as well. And if you watch Scott's original video, he goes into this in more detail. His argument is the try-catch blocks are just another form of the pyramid of doom. They're not nested, but they might as well be. Yeah, and especially the larger blocks, they need maintenance as well, and they start to become fragile. So we'd rather not have them if we can avoid them. So that one's got consequences, and maybe you can live with them, maybe you can't. That's for you to decide. Second option was return, take advantage of this dollar failure and return an error of some kind. I can always see heads shaking. This is going to be fun. Yep, going back to our diagram from earlier. It's there. The whole point of it's there. It's clear we want to use it. So here we go. So we set failure to something, and then we return a value and the failure. That's what we're doing. Okay. Excuse me. This also has consequences. Go on.
You've refactored to get that rate. Get that rate was taken an array as its second parameter earlier.
You are
It was taken back.
absolutely right. There is a bug in that slide.
You've magically invented failure. Yeah, I don't want you doing that, but I would have an exception for the inner one and catch it in the outer one because failure wasn't going into the inner.
No, this is our builder. This is our builder. No, this is actually our builder. And this is good because this is highlighting a problem caused by these builder functions and all the boilerplate that comes along.
Yeah, sorry, I see where you are now.
Yeah. So that's an important thing to point out, is the fact that we're challenging now whether this code is actually as easy to reason about as I believe it is. And that's where that generic partial builder, the runtime cost may be worth it, because it gets rid of this readability problem. Where's that code coming from?
This is a we're creating a function.
Yes, you jump out var that's passed because you're telling a function, so is it call time to pass it?
Yeah.
You know?
Line 3 of the example, it's a parameter into the function that we're
You
returning.
haven't called that yet, right? You return a function signature, so then you call it later.
And then we call it later. Down at the very bottom, we're passing in that code of A and Q. Yeah. But this is good because this is starting to challenge my score now about whether we can reason about this code or not. So this is very important.
So the only issue with this, earlier you said we're not allowed to change that float to float question mark.
Yep.
That's kind of issue what you're doing here. You're not changing it to float question mark. You're changing it now to an array with who knows and who knows.
Yeah.
Right. And
so
you're refactoring that function as I think it was Rob, was it? Which realistically you said we weren't allowed to do, which is why we said it.
Well, I suggested that you might not want to do it for testability purposes. You might find that leaving the ROP signature out was easier for you to test. Yeah. And I said, you need to go away and play with that and see, because I don't know the answer. I believe that's what I said earlier.
Could be wrong. Yes, you did.
Yeah.
I don't think I would affect it.
But you're absolutely right that I have refactored it. Absolutely right. But the other thing you're right is this thing, the main consequence with this is by doing this refactor, we've got to agree now what $failure is and how everyone's going to use it. We can't avoid that any longer. We've been kicking this can down the road, it's time to sort it out. And whatever it is we agree on, everyone who uses this code has got to agree on it. Okay, that's an unavoidable consequence. I know it's obvious, but it does need pointing out to people, I think. This is my problem with this, is we're still returning data. Because we're not returning a null because we want it to be composable. We're still returning something on the main data value as well. And we're relying on people to check that $failure now actually has a meaningful value. And this is where for me, this approach breaks down.
Yeah, you're saying this is returning two tracks.
Yes.
And constantly returning two tracks.
Yes.
Now there's a failure.
Which is where I'm varying from Scott's approach.
Yes, exactly.
Yes.
Okay.
Yeah, I'm varying from Scott's approach, and it will make sense when we get on to option 3. Okay. Because we're gonna close that circle. But you're absolutely right. Yeah. Now, problem is option 1's effort and introduces fragility into the code because it's basically how we already do things. And I'm on this quest because I'm fed up with how we do things. It's not delivering what I want. Option 2 requires humans to do this error checking 100% accurately and checking that failure's got a value in it. Doesn't happen.
I prefer option 1 at this point.
Yeah. It's like templating libraries that don't do auto escaping, and you have to do escaping all the time. And Rob knows exactly which library I'm on about. In reality, people don't do it. You can't rely on people to be getting things right 100% of the time. It doesn't happen. And I've seen those mistakes cost millions of pounds at scale. So I think both these, I don't like either of these options. So I've got a third option, which I haven't heard in the room. What if the caller tells us what to do? So the function doesn't decide what to do, the caller does.
I've seen that.
No, that's
before.
exactly what I was talking about.
My apologies then.
No. I didn't explain it that way.
Okay.
I didn't know you like functions and functions.
No, I passed the function.
It's different, right? It's not it's an argument.
I passed a function. I passed a function that tells. Sorry, I passed a function 3 arguments in a lot of cases where I have the test and then on pass and on fail.
Okay.
Okay, and I have 2 branches that way. So
Okay.
if it passes, you pass off to this function. If it
Yep.
fails, you pass off to that function.
Okay.
The function doesn't know what function it's going to get.
Right.
Okay, so the output is completely independent of the function.
So, yes, that approach. Slightly different signature, but that approach. So what we've got here is our failure now has a definition. And it's a callback, effectively. Yeah.
Do you remember, I don't know if you remember, anyone remembers, it's actually very similar to the jQuery thing I was talking about. When you made an Ajax call back in the day, you pass it the body, and then you pass it a success function and a failure function. Do you remember that? Yeah. That's kind of why this is
call that current JavaScript.
Oh, what?
Current JavaScript. Not JavaScript.
And we can take advantage of, did they call it the coalescence operator? I can never remember the name of this one.
Yes.
Nil coalesce.
No coalesce, thank you very much. But we can take advantage of the fact that if we can't get a value, we just offload it to the callback. It's their problem.
JavaScript was just like pipe, or.
Yeah.
Just like do some shit, or
Yeah.
let's go away. I like it.
Interesting.
Yeah. And then what we do to keep our composability for our functions is we pass back whatever on failure has told us, and we pass back the callback as well. So it's also the callback into the next function down the pipeline, if there is one. And this is how we get around the fact that I'm using 2 railway tracks, as Scott doesn't. We've actually got...
With that, is that on failure has to return a string.
Well, in this case, on failure has to return a float.
So
In this case.
But
No, it can't.
failure has to return.
you can't do it because this function takes a string.
And it returns, and this function returns a float. Actually, it's not actually typed, but if it was typed, it returned a float. Get VAT rate returns a float.
This would be like on VAT rate failure function.
Yep.
And it would have a return
We can't.
What hold on. Are you saying basically that the function that on failure would be returns the float or a string?
Yes, it has to work.
In this case, it would have to return a
I
float.
thought
In other words,
Return
a
a
table
string.
could contain a function. That's the question.
That's...
Sorry, not a table, but an array. Sorry.
Well, as a C programmer, that's how I'd have sorted it, because I'd have used function pointers. Yeah.
In order to compose this
Yeah.
function into the next function,
Yeah.
the next function has to know it accepts a float, not a string.
The callback has to know it accepts a float. It needs to return a float in this case. Yep. Hold that thought. Hold that thought. Yep. Hold that thought. But we can make, the thing is, we are defining on failure at the point we use this code. So we can decide it's going to do something. Now this actually should be returning a value rather than just echoing a string. But we can make it do whatever we want within the limits of the function we're calling, yeah? And it can throw an exception if we choose. Yeah? It's a choice now, but the library doesn't choose, we choose.
Yes,
And we're
which
going-
is why jQuery does the same.
Yeah, and we're going to get back to that in a moment. But we've taken our function, which before we were drawing like this, and we've now said it looks like this. And we've said that in PHP with this implementation, this is what ROP looks like diagrammatically as a generic case. So we don't quite have the same 2 railway tracks that Scott does, but we're achieving the same effect by adding this callback in. That's how we're doing it. Now this still has consequences. You've still got to agree what $failure is, and as Rob's rightly saying, there's a lot to agree about it. $failure is, I said for ages it was optional. It's no longer optional. You always have to provide a failure handler, which means you've got to know what it's got to do. And that can be problematic when used in anger. The caller whoever's using this business logic, they decide what happens when there's a problem now. The library doesn't decide. And they can throw exceptions if they want. Keeps everybody happy, I hope. So if you still want exceptions, then try catch block, because in this case you believe you're not introducing fragility because you're controlling the exception very specifically that's being thrown. It's not an exception buried 20 down in that dependency graph anymore. You've now got that capability, and hopefully it should be less fragile. It actually is in practice. I actually use this already in an application, and it already is a lot less fragile. And very quickly, I just want to mention that the partial builder changes slightly, because now our second parameter that it's building is typed to say it's a callable. But that's all we can say. We can't say what parameters it should be accepting because we don't have function typing yet in PHP. And this approach would be a lot stronger if we did have that.
You end up implementing interfaces and loads of different partials or something. It gets very messy, right?
Well, no, you define you define function types and function signatures.
If we could.
Yeah, we're not.
Yeah. That's how we used to do it in C. So, but we don't have that capability today. So let's park that one. So I think that tackles our robustness. Yes, please.
So at the beginning,
Yeah.
well, no, let's ignore that. Assuming you don't go through the exception route when you do your error handlers,
Yeah.
the error handler always has to return what the function would have returned or the
Yes.
set type. So in that case, you always go to the end of the train tracks, whatever you do,
Yes.
even if it's failing in the middle.
Absolutely.
And the functions that happen after and after and after, they're just going on some kind of dummy, whatever got returned.
They are.
And also, your errors aren't tallying up, like you said. You said you like the idea of like,
You can, because there's no, that error handler can actually be building up an array of all the errors it's captured.
Can you pass that
And it can be doing that.
so it can accumulate?
It can accumulate. It can hold a variable inside.
It's like state. you
as
pass
in like a static variable inside the.
It doesn't have to be static. It doesn't have to be static.
So,
I don't think.
because it's put into that function, you
Yeah, it doesn't
touch
change
it,
that.
and then you pass it to this guy, and then
Yeah.
he goes, "Oh, I'm going to add something to you," and then.
Or it could be writing to your logs.
And functions passed by reference.
Functions passed by reference. No. No, they are passed by handle. The only things passed by reference are, no, objects are passed by handle.
But it's not passed by value, in other words.
It's not passed, functions not passed by value, no.
No, it's just a pointer to a symbol table.
Mm.
Every page.
So you can put a local verb inside that,
Yes.
call that outer error thing, and it will propagate all the way through.
Yeah.
Yeah.
Until there's no ref counters, and then you go pop.
It's stuff that you have to use this.
I think you have got to use static, but you can use it.
So that's what you. So that's the methodology. You use the same error handler for all the different functions because
Yes.
you pass one in the
Yeah.
first place, and it gets reused throughout the whole thing.
Yeah.
And in that you have a static array of errors, let's say.
Yeah.
And you just keep pushing to it.
Yeah. But remember, you can write an error handler right before you call the logic, so it's local to that. It can be. You can write hundreds of these things throughout your app if you want to suit that particular circumstance.
Because you go build the pipeline anyway,
Yeah.
and the pipeline isn't generically reusable. Because you've got to be aware of what type is coming out of any given thing to go into the next.
You've got to be careful with it. There's consequences, that's for sure.
There's
That's why I'm a
difference
bit
between
concerned about that float.
there's context. I think there's a context of the builders and there's context of the functions. Functions are stupid, but the builders are the ones that understand the context and will do any like who came before me or what have we given them. Is that right or not?
No, it's the it's not the. It's actually the pipeline that knows what comes before and afterwards, because the pipeline is the only point that the actual wrapped functions get called. Someone has to build the pipeline, and I've got a slide on that in a moment about that to finish. Yes, please.
Okay, you're talking about building. Everybody, we're all talking about calling a function.
Yeah.
Okay, at the end of after each one is called. Okay, the error is a function that's being passed. Is that why don't you, instead of doing that, because each one has to know how to handle that, why don't you just pass an array and then add to that array and process that array at the end?
Because if it was always an array, you can't short circuit. If you want to short circuit, you can't do that if failure is an array that you're appending to. By making it a callable, you've got complete control over that logic.
I see.
In PHP we can't peek inside arrays. We just know it's type and if it's empty or not, really. And we can look inside that as we traverse it, which is something.
Right. No.
But we want the flow logic outside.
As soon as you say, yeah.
Yeah, I've got a slide for that in a moment.
I just think you've.
Confirming the short circuiting is only doable by throwing an exception in the handler. Right?
Yes.
Just make sure.
Is the handler the builder?
No, the handler is
The original guy?
no, the handler is the error, is the on failure callback. The error
Okay,
callback.
got it.
Okay. No, actually, no. Back to the screw with the array. If you're building a group of these little track segments and so forth.
Yep.
At some point, you're going to want to know, in some standardized manner, what's happened throughout these particular units and so forth. If it was an array, then you would know, or you'd be able to process it no matter where you were in code. And you'd be able to build those things together in any
And
fashion.
if you want an array, this approach allows you to do it. But this is all relevant to this discussion about pushing, you're going to let me push this reusability score up. My argument is this callback actually makes it more reusable because you can have your approach, Rob can have his, anyone else who wants a different approach can have theirs without having to change the function itself. The function where the logic is, that doesn't have to be changed.
That was never even a question about changing the function's logic.
And by using a callback, it's the only way to give everyone what they want. Because, and this is the point I want to make, is this, I mentioned earlier this term policy. These error handlers are not in the reusable library of code. They're in your application. They're at the point of consumption instead. We define them right before we call the pipeline. And they're specific to every pipeline I found in reality. I never reuse them for more than one pipeline. I always write a new one every time. But also has the advantage as things change over time, you don't break existing pipelines. And my argument is that allows us to meet all three of those criteria. Although, which I think is awesome, the discussion has shown that there's sort of other questions that need to be answered about that. I promise you that's the last slide. At 1:48. This actually timed out at 1:15 when I rehearsed it last night. So that just shows you how much discussion this talk has generated. And I think that's important because instead of me coming up here droning at you for 50 minutes and then you all going down to the bar, we've had a two-way discussion where we're challenging these ideas, we're challenging these concepts and seeing if we can improve them or whether they're junk and they should be thrown away. And I think that's very healthy. So what do we think? Does anyone like to go and do this on Monday at work? Nope. There's some very firm shakings of the head down there.
It's a variation on middleware.
There's a variation on middleware. Well, like, ignoring the fact that I hate the way middleware terms have been hijacked.
It's come up because it's
Well, the middleware is a pipeline pattern.
Yeah,
And you can use the word pipeline here because it's say.
Are we creating code that can be composed as a pipeline? Yes.
You can swap. We're going to use the word middleware because it came from Ruby, sorry. But you can move the middleware around for any given application independent of what each piece of middleware does.
Yes.
Which is basically what we want to be able to do in that business.
But the other thing we've done, if you look at PHP middleware, I'm not familiar enough with Ruby's to comment, but with PHP middleware, a lot of these things I'm challenging about reusability are baked into that middleware. They're not controllable from outside it, which makes it, you can use them as large lumps if their context is your context, but taking it to try and use it, if your context is different, the reusability is often very hard.
they're very isolated, I think.
It depends upon the level you're looking at. And if you look at what we did before we had middleware in our HTTP pipeline, we couldn't change anything.
No.
So we have more reusability than we did have.
Let's go down and hit the bar and let's carry on the discussion down there then. Thank you all for your contributions.
Thank you very much, Stuart.